Hello everyone, I am Sini Shibu from the Department of Computer Applications, and today I will be talking about a very interesting topic, that is recursion. We have come across recursion many times in programming, but today let us understand what is recursion and how does it work internally. The learning objectives of today's session would be that after this session, the learner would be able to define recursion, understand the control flow during the recursion process, compare recursion with iteration, and know about the various types of recursions. Coming to the topic of recursion. In programming, recursion is a concept that is very widely used. Let me explain with the help of an analogy. Here, in this analogy, we have a young mother who wants to get some milk. So she asks her daughter Anu to get some milk. But Anu doesn't want to go to the shop. So what does she do? She calls her brother Arun and she asks Arun to get some milk. At last, poor little Arun has to go to the shop and get the milk. Now in this analogy, there are a few things that we need to observe. The first observation is that the same function call is being made with different parameters. Here you see we have a getMilk function which the mother is using with the parameter Anu. The same getMilk function is being used by Anu with a different parameter, that is Arun. The next observation that we have is that there is a termination condition. Unless there is a termination condition, this would be an endless process and the mother would never get milk. So at the end, Arun has to get milk from the shop and that becomes the termination condition. The third observation is that there is going to be a return of item. The return of item in this analogy being the packets of milk. So when Arun gets the packets of milk from the shop, whom does he return to? He doesn't return it to mother because he doesn't know that mother is the one who has asked Anu to get the milk. So he would return it to Anu and finally Anu would return the milk packets to her mother. So with this analogy, I want to make the recursion process explainable in terms of programming. In short, a recursion is a function which would call itself repeatedly until a certain condition is met. Every iterative program can be converted into a recursive program. In this example, you see two programs which would do the same operation of finding the factorial of a number. Let me first come to the iterative program. This iterative program uses a for loop which would go ahead and iterate n number of times and calculate the value of the factorial. The same iterative program, when converted to the recursive program, you would find that the recursive process is called again and again with different parameters each time. To make this recursive program more understandable, let me go through the control flow. Here, in this example, we have answer as the variable which is calling this function fact with the parameter 4. When fact function is called, this function is going to call the recursive function fact. Now the 4 value, which is the value of the number whose factorial we need to find out, this number gets passed on to the value n. Hence, n gets the value of 4. Next, when the value of 4 is passed on to this n variable, we go inside the code and this is what is happening inside the code. We are creating a variable y and now the check condition is if n is equal to 1, it would return 1, but n in this case is 4. Hence what we would do is we would go to the next line of execution in which the factorial is going to be called with a parameter n minus 1. So another function call or a recursive function call is being made, and you would find that the system would go ahead and make another call to the same function factorial. Here now n minus 1 value which will be calculated as 3 would be passed on to this n variable. Now again, since the condition is not being met, it is again going to call for a recursive function fact with n minus 1 as the parameter. Here n minus 1 now becomes 2. When 2 gets passed to this function, again the condition fails and there is a recursive call again to the factorial function with n minus 1 parameter. Now n has got the value of 1. We would find that this satisfies the termination condition, and hence now the return of values would begin. The first return is a value of 1 which is returned to the y of the calling function. Another return is an n cross y, which in this case transfers the value of 2 to y. Another return value is n cross y again, and this would return a value of 6 to the calling function. Final return is to the answer variable where n cross y evaluates to 24, and that becomes the final value of the factorial of 4. Hence, the main program would go ahead and display 24 as the value of the factorial of this particular number, which is 4. Here you have seen the control flow of all the recursive processes and the return values. Let me now go ahead and compare recursion and iteration. The basis of comparison, if we talk about termination, the recursion is going to be terminated based on a conditional statement. In the previous example, we have seen that an if condition checks whether a return value has to be given or whether it needs to continue with the recursive process. In iteration, the termination condition is controlled by a variable. In case of an infinite execution, there would be a system crash if we are running a recursive function. But in case of an iteration, there would not be a system crash, but rather CPU cycles would be consumed and the system would go on evaluating the iterative process. A function call is required in recursion because recursion definition itself says that it is a function which calls itself repeatedly. There is no requirement of a function call in case of an iteration. If we talk about the length of the program, in case of a recursion, the program length would be shorter, and in case of iteration, the program length would be longer. Now let us talk about the various types of recursion. The example that we have seen right away is a direct recursion. A direct recursion is a case where the function calls itself with different parameters. So if we have a same function calling itself again and again, in that case it would be termed as a direct recursion. As an example, let us go ahead with the same example that we took for calculating the factorial. Here you see that the factorial function is named as fact, and in the fact function, again the fact function is called recursively with a different parameter. We have already seen how different parameters are going to be evaluated and returns would be given in case of recursion. This is the most simplest type of recursion, which is known as a direct recursion. The second kind of recursion is known as indirect recursion. Indirect recursion can be considered as multiple functions calling each other one after the other. So it may be a circular call and one function would be calling the other may be calling still another, and the last function may be calling the first one. So let us look into an example of indirect recursion. In this recursion, you would see that we have two functions, functions A and function B. Function A is calling function B, and function B is calling function A. So, in this case, we would notice that the indirect recursion has multiple function names. It is not the simple single function that is being evaluated, but there are multiple functions in play, and the one function would be calling the other function one by one, and the process continues. The third type of recursion is known as a tail recursion. In a tail recursion, there are no pending operations on return. For this, let me take you back to the example which we had seen earlier. So, if you go ahead and see the recursion example, you would see that there are multiple operations that are being done, and after the return also there is one operation that is return n cross y. After every return, you are going ahead and returning a value and then computing another return function so that it could be returned to the calling function. So, this is an example of direct recursion, whereas in tail recursion, we will not have the case of any pending operation on return. This is an example of a tail recursion. Here you would see that there is no statement after the return statement. The return statement would be the last statement in case of a tail recursion. There would be no operation which is going to be executed after the return statement. So, with this I conclude my session.